طيب يا شباب. Let us continue from where we started last time. Last class يا شباب, we talked about the entropy change of an idea, which is part of chapter 3, which we introduced regarding entropy, the definition of entropy, and the entropy change. Okay. Um, so. So we introduced entropy and the tedious equations for that can be used to evaluate entropy and its relationship to all other properties. And then we showed how we evaluate this for example, ideal gas here. Okay, and we derived the equation that can be used to evaluate the entropy of an ideal gas and using the ideal gas table as well. Okay. So this is from last time. Today, inshallah, we will talk about, we'll continue this discussion, and we'll try to look into the entropy change for internally reversible process of a closed system. Okay. So we'd like to look at the entropy change. Okay. In internally reversible processes of closed systems. Okay. So you have a closed system, and the system is undergoing a internally reversible process. How do we evaluate the change in this case? So as a reminder, let's look at the that we used for the ds. Okay, if you remember, we defined ds as dq over t. Okay, and we also defined it when we proved this integral. We proved this integral is a property for internally reversible process. Okay, so let's write it for now like this. So ds is dq by t. Okay, so let's look at the change of heat transfer. So what do you notice, Shabab? So once I have higher heat transfer, okay, so now if imagine my dq is high or is increasing, what does this affect ds? What happens to ds? Huh? If dq is increasing, what happens to ds?
will increase too.
Will increase.
It will also increase, right? طيب, if dq decreases, what happens? ds will also similarly decrease. What does this tell us, ya shabab? What does this tell us? This tells us that entropy transfer also. Okay, so transfers or entropy transfer accompanies ايش يعني accompanies؟ يعني يصاحب accompanies heat transfer. معقولة يعني once we have heat transfer there will be entropy transfer? Unfortunately, this is يعني life. Okay, once I have heat transfer, entropy will all transfer. So, and this is one important concept to understand. Okay, so entropy transfer accompanies heat transfer. All right. طيب, imagine I have a process where the entropy is constant during this process. What do I call this? I call this isentropic. إذا سمعتم يا شباب isentropic process. Isentropic process. It means a constant entropy process. Okay, and this yeah, so this is just one more process. We defined a lot of processes, if you remember, Shabab. We said isochoric, isobaric, isothermal, adiabatic, and this is now isentropic process. So isentropic process refers to a process where the entropy does not change through the process. Okay, which makes it what? Which makes it internally reversible process. That's the idea here. Okay, so let's look at the let's look at this equation of, let's rewrite this dq in terms of TdS. Okay, because I would like to talk about the area representation of the heat transfer. Area representation of heat transfer. Okay, so if we look at this equation here, السؤال في أي سؤال يا شباب على اللي قبل what I just discussed? Any questions here? Any questions about this? We said the entropy transfer accompanies heat transfer. This is important. And then isentropic process is a process where the entropy is constant or does not. Okay, that's all what we discussed here. Now I would like to talk about the area representation of heat transfer. So if we rewrite the definition for the entropy as d for internally reversible equals T ds, okay, then if I would like to, if I integrate here, so the heat transfer for internally reversible process equals the integral from state 1 to state 2 of T ds. طيب, what does that mean? It means what's the integral of CDS is just the TS diagram. So if we look at the TS diagram like this, okay, and then you have certain process from state 1, for example, to state 2, okay, so the dq equal TDS, you can think of it as this infinitesimally small area like this, okay, so this is basically, this is ds here, okay, and this is TDS, and this is, so this is T here, and this is basically the dq for internally reversible. Okay, so this is only valid, this is what you need, ya shabab, to remember here. So basically this q is basically what? It's basically this area. So q here in this case is the total q is basically this total area under the TS diagram. Okay, and one thing important you should note that this is valid only for internally reversible processes. Okay, so this definition of Q is area under the curve is only valid for internally reversible process. لأنه there is no other effects affecting is only the temperature change. Okay, so any questions here?
يا دكتور internal reversible process تقدر تعطينا بس كونسبت بسيط عنه لأنك أذكر شرحته مرة بس نسيته.
ايش يعني reversible؟ يعني once I do it in one direction I can reverse it in the other direction. As simple as that يعني.
والinternal اللي هو ما له دخل بالباوندري صح؟
هو الانترنال. احنا قلنا internal لانه inside the system. external اللي هو on the boundary. That's the difference.
أوكي.
اوكي. فعندك internal reversible يعني I can reverse it. عندك water I condense it بعدين I evaporate it. I can do it both ways. This is internally reversible. اوكي. لكن تخيل عندي gas ما في تانك بعدين I open the tank the gas goes out the tank spread in the environment. I cannot bring it back. خلاص راح. This is internally not reversible or irreversible process. فهمت الفرق؟
أيوة.
واضح؟ Good. Any other question? Any other question? Let's look at an example actually for this definition of the heat transfer that we can apply in example cycle that we actually studied before. Okay. Do you remember يا شباب الكارنو cycle? So Carnot cycle application. Okay. So if we plot يا شباب in the Carnot cycle, we said it consists of 4 reversible cycles, 2 adiabatic and 2 isothermal. Okay. So if we try to plot this Carnot cycle in a TDS diagram, this is what we get. This is S, this is T. So we have state 1 here, state 2, state 3, state 4, and then back to state 1. Okay, so if you remember, we said 2 adiabatic. So this one here, you have heat transfer from the hot reservoir. Here you have heat transfer here from a hot reservoir to the system, and here from the system to a cold reservoir. And then we have, sorry, I think I flipped the, yeah, I think, yeah, sorry, this is the opposite. So this is 2 here, this is 3 here, okay? So 1 to 2 is is a reversible process. Is here this is the adiabatic process 1 to 2, and then isothermal 2 to 3, another adiabatic 3 to 4, and then 4 to 1 is another isothermal heat rejection or heat loss. Okay, so if you look at this diagram, now this TS diagram is for a Carnot cycle. This is for a Carnot cycle. طيب, let's calculate the efficiency يا شباب. Let's derive the efficiency using the area definition we just had here. Okay. وضحت ايش نبغى نسوي؟ I want to calculate the efficiency. What's the efficiency here يا شباب؟ What's the efficiency for this cycle? Output over input. Where is the output?
QC.
الأوتبوت وشو؟
QC.
work.
Network output divided by Q hot. صح؟
Yes.
طيب Q net احنا ايش قلنا ال Q net؟
H minus Q cold.
Q hot minus Q cold over Q hot. طيب let's see how can we how can we rewrite this يا شباب؟ okay. احنا وش قلنا برضو؟ let me write it actually in this way. احنا ايش قلنا في ال closed system or for a cycle؟ قلنا for a cycle the work net equals qnet صح؟ okay.
Yeah.
So I'll just write qnet here, which is same as q hot minus q cold, right? So let's try to look at what is the q hot, what's the q cold in this case. So based on our definition, q for internal reversible process is the area under the curve, okay? So for the q hot, which is this one here, what is the area under the curve?
It will be QH minus QC multiplied by the width.
The process from 2 to 3.
It's from 2 to 3, right? So q hot equals, so the area under the curve, this is a isothermal. So basically I have T will be constant, right? Let me put the from 2 to 3, right? T ds. So T is constant here, which is T hot in this case. So it's T hot times, ها شباب يلا اللي هو ايش؟ دي اس بيطلع اس بعدين 2 to 3 وش يصير؟ S3 minus
S2.
مع
S2.
يا شباب والله ضايعين يعني وش السالفة؟
كتبته.
معك.
So T hot 3 minus S2, right? Okay. طيب let's look at the Q cold. Q cold اللي هو ايش؟ The Q cold will be basically this area here. Okay. وش بيصير؟
Same T.
بيصير Q cold اللي هو from 4 to 1 صح؟
أيوه.
مظبوط؟
صح ايه مظبوط.
اللي هي T ds يعني T cold times S1 minus
minus S4.
okay. طيب الآن what is the total QNet? What is QNet الآن? QNet is basically kind of the total, right? So it's T hot S3 minus S2, right? Plus
Would be minus.
minus.
لا أنا الحين أنا بقول لكم ليش أنا حطيت from 4 to 1 لو حطيت from 1 to 4 بحط الماينس لكن
So it's already flipped.
exactly. So I already put, so now I want to find the total is Q called, so S1 minus S4. I can rewrite it. Let me rewrite it actually. Let me put minus T called اللي هو S4 minus S1. Okay. خلاص, if we open this يعني if we open these and take يعني simplify these further, what we eventually have, and if we do this, what we eventually have is T hot minus T cold times S3 minus S2. Okay? S3 minus S2. ليش؟ لأنه هنا لو تلاحظون إيش؟ S3 equals S4. This is what we need to notice. So S3 equals S4 و S1 equals S2. صح ولا لا? From the figure. Yeah. Okay, so using this information, then we come up with this final form of the QNet. Okay, طيب خلاص الحين وجدنا ال QNet. Let's write the efficiency اللي هو T hot minus T cold times S3 minus S2 What is the Q hot? T hot times S3 minus S2. Okay, so what do you notice here? I can cancel this one with this one. I end up with T hot minus T cold over T hot, which is exactly, ya shabab, what we derived before. Subhanallah, yani, this is exactly the same result we derived before.
والله لفة طويلة يا دكتور.
ها شفتم كيف the concept of internal reversible, and this is a reversible cycle, which is a Carnot cycle, and then I use the concept of the entropy change, the definition. It gave me exactly the same result. Okay, so this is the importance of applying reversible cycles and using the area representation of a heat transfer. Okay, and this is only applied again for internal reversible process. Any questions here? Any questions? Any questions?
No, I think it's clear.
Okay. All right. Okay. Right. Let's move on. Should we take a more example? Let me take one example here. Shabab, let me give you an example here with numbers, yani. And you see how you can extract the values from, I guess, from the tables, right? And then also you can use it to calculate the work and the heat transfer. So let's see this example. So again, the system of piston cylinder. Okay, so I have a piston cylinder arrangement. I have water here inside the cylinder. What happens is initially this water, so initially the water is at saturated liquid state, okay, at 150 degrees Celsius. Okay, so Celsius, and the initial phase is saturated liquid. So we started heating it. So we started adding heat to the water until the final state. So the final state is saturated vapor. Okay, the final state is saturated vapor. And I'm telling you here, assuming, so this piston is freely moving, so there is no friction, so we can assume this is internally reversible. So assuming this is internally reversible, process, so this heat transfer that I'm adding is internally reversible process at constant temperature and pressure, and the question is, find two things: the work per unit mass, or the specific work, and the specific heat transfer. Okay, so this is what is required. So yes,
freely moving له علاقة بinternally reversible.
of course. وابغاك انت تجاوبني ليش؟
هذا انتروبي دكتور، يعني ما يكون ما عندنا هنا انتروبي.
مضبوط، خربت علينا بس صح. هو لانه هنا فريلي موفينج معناته ايش؟ وذكرتها قبل شوي انا اتكلم عن السؤال، ما في فريكشن، والفريكشن is irreversibility. It will cause entropy generation. Once you have generation for entropy, this is irreversible process. Okay, so internally reversible does not have any irreversibility. So if you have a process which is reversible, so irreversibilities are not present. What are these irreversibilities? Friction, heat transfer. لأن الفريكشن هنا عند الوول بيسوي heat transfer على الوول، فبالتالي بيخليها يعني the boundary is مثلا another heat transfer which you don't want. Okay. At least in this example. So again, so we have saturated liquid water at 150 degrees Celsius. I added heat in internal reversible process at constant temperature and pressure until the final state, which is saturated vapor. Find the work and the heat transfer. So for the work يا شباب, you should be able to do this. يعني I guess this is expansion or compression work, right? So how can we proceed?
Yes.
So what is work? Start from the end. I need the work. So what's the work?
B multiplied by V2 minus V1.
So the integral is P dV. Let's start from the basics, from state 1 to 2. P dV. This is a constant pressure process. So I can say P, since this is by mass, so I'll have this is specific here, right? dV. So it's going to be V2 minus V1. So what do I need here? I need the volume, specific volume at the first state and the specific volume at the final state. And how can you find this?
Which is VG minus VF.
Which is exactly. So P is going to be the saturated, right, at 150 degrees Celsius. صح؟
Yes. Which
وال
is
V2 اللي هي ال G state وال V1 اللي هي ال F state. This is simply the work. طيب الهيت ترانسفير يا شباب. الهيت ترانسفير. I want to give you another.
You can find it from the delta U.
Exactly. So if you remember what we used to do, we used to say delta U equals اللي هو Q minus W. So this is M delta small u Q minus W. So I can write delta U equals Q over M minus W over M. So I have this one, right? And I can find this one and then evaluate eventually this one, right? That's what we used to do. Now, يا شباب, since this is internally reversible process, since this is, I told you it's internally reversible process, what can I do? What can I use? I can use simply what?
I can use the difference in entropy.
Exactly. So from 1 to 2 TDS. And then if so temperature is a constant temperature process. So this is T, right? Then S2 minus S1. So let's write it in terms of, again, small s. So this is ds, 1 to 2. So you have T S2 minus S1. What is the temperature here? Is T saturated, which is the temperature that I have here, right? Times S2 اللي هي SG minus SF. This is directly can be used to calculate the heat transfer. So once you have that, يعني عندنا القيم, okay, directly, خلاص we can just upload, يعني plug in numbers. And if you do this method يا شباب and compare it with what? If you compare it with or اللي هي Q over M equals دلتا يو اللي خلينا نقول مثلا هنا U2 minus U1 U2 minus U1 plus work over M. If you do this method يا شباب, you will see that this is exactly is gonna match this value. So if you do this compared to this will directly give you exact same numbers. Okay. Let's look at here. The other thing يا شباب, one last thing here يا شباب, إنه this method also, this work, if you notice, I can rewrite this equation, which is the last one I wrote here, equals U2 minus U1. الورك ايش قلنا احنا؟ P delta V صح؟ plus P V2, right? Minus P V1. What is this يا شباب؟ اللي هو U1, this one here and this one here. What is this? U plus PV.
مثال
which
B.
تعطي؟
مثال بي.
مثال B.
Exactly. So this is actually eventually equals H2 minus H1. اللي هي ايش؟ HG minus HF at 150
والله في
degree.
خطوط كثيرة يا دكتور.
يعني شوفوا كيف يعني three methods. I can use this one direct, this one after calculating work. I can simplify it to enthalpy change, or I can use all of this will lead to the same thing, which goes back to the main concept. Okay, and this is, you can see this is يعني this method is because we said this is internally reversible process. Okay, we approximated it as internal reversible process, and if you actually do it, you will see that it's similar result. Okay, because some problems in thermodynamics we can approximate it as internal reversible process. So, but here the important thing is you understand the basic concept behind internal reversible process and the way to calculate the properties or evaluate properties and eventually evaluate heat transfer and work done. Okay, that's why I'm giving you these examples, so your mind will practice these things عشان لا تقولون اختبار صعب. Okay, so now we have all of these concepts to look at. Any questions here? لو تلاحظون this example is just a simple basic example that I used to give you يعني all the time. Okay, يعني ما في شيء جديد في السؤال، بس الجواب شوفوا كيف based on your knowledge, based on the new concept introduced, I can calculate it differently. All right? Any questions? Any questions? معقول شرحي خطير يعني؟
ايوه رهيب دكتور.
طيب جزاك الله خير. طيب اوكي. Quickly يا شباب, should I stop here لأنه this is a new topic, entropy balance. So I want to talk about the entropy balance. Let me talk about it, introduce it quickly, and then we continue next class. Yeah, I think I have time. So the second thing I would like to talk about here, which is a new topic now. It's not entirely new, but as a main topic. So I would like, yes.
It's just to take more examples because I think we talk many concepts this last 4 classes or
في examples coming. الحين أنا بعد after I introduce this inner entropy balance, I will take more examples. يعني عندي 1 2 3 I have examples يا شباب. but it's regarding لأنه هنا وش الفكرة في ال Q وال W. This is old يعني topic يعني there is nothing new في الexample هذا اللي أخذناه. This is just to evaluate work and heat. لكن once we do the entropy balance, we can take more examples, which will also, I think, will involve work and heat. So let me just introduce this, and then we'll take, inshallah, more examples. Okay? Sounds good?
Okay.
So I would like to talk about the entropy balance. And I think I talked about this briefly when I started in chapter 5, if you remember. Entropy balance for closed systems. Okay. All right. So what did we say, Shabab? We said if we have a closed system, and then the only way the energy can transfer is either by heat transfer and work, right? So this is a system, closed system, and we have boundary, okay? And from what we discussed, ya Shabab, we said the change in entropy of the system, okay, we have internal generation of entropy within the system, and since we have heat transfer, entropy will also transfer through the boundary, okay? So we have entropy transfer, and then you have internal entropy generation. So basically, the entropy change within the system, which is, I can call it, before going there, let me just remind you about the energy balance. What did we say? The energy balance is the change of the energy of the system equals Q, which is energy transfer into the system, minus W, which is energy transfer out of the system. For the entropy balance, we'll do something similar. So we have the entropy change within the system, okay, equals, you have what? The entropy transfer across the boundary, اللي هي هذه. I'll call it also ds here. And then for just not to confuse, I will call this sigma. Okay. واضح يا شباب؟ sigma اللي هو internal generation اللي هو entropy generated, with ds اللي energy transfer through the boundary. Total entropy change within the system, okay, equals, ها شباب وش الانتروبي transfer؟ وش قلنا الانتروبي transfer is related to what? accompanies
heat
الهيت
transfer.
transfer. So وش الديفينيشن اللي نكتب هنا؟ بنكتب هنا something plus something اللي هو واحد حق الترانسفير across the boundary وواحد حق الانترنال generation. حق الانترنال ترانسفير حق الباوندري across the boundary is what؟ ها؟ الانتجرال صح؟ ها؟
Yes. QS over T.
dq over t.
Yes.
Okay. طيب what about the internal, which is we call it sigma. Okay. So this is basically the change. So this is the entropy change within the system. This one is the net entropy. أنا ليش أقول net؟ لأنه ممكن يكون عندي heat transfer from more than one location. Okay, so this entropy, net entropy transfer across boundary, which accompanies heat transfer. Okay, and then this is sigma here. This is called entropy production. Entropy production due to other irreversibilities within the system. اوكي. سو يعني يعني انتم شايفين انه الباوندري الهيت ترانسفير through the boundary is very very important in the entropy balance. يعني it's one important term by itself compared to all other entropy production that can be generated within the system due to other sources, other okay. So this is basically the general equation. واضحة شباب ولا في شيء مو واضح؟ واضحة ولا مو واضحة؟
اي دكتور واضح، بس عندي سؤال بس.
اسأل.
اللي هي اللي داخل انتجرال هذه دلتا كيو ولا اس كيو؟
لا هذه دلتا كيو دي كيو، بس قلنا احنا الدي هذه حقت البارشل، هذه بارشل.
ايوه
بارشل
فهمت
فوق.
كلامك.
اوكي.
يعني دكتور طيب السيجما هذه كيف نحسبها؟
كيف تحسبها؟ طبعا هذه واحدة من الأسئلة بعدين في الإكزامبلز، إنه find the entropy production بكل بساطة from this balance equation. يعني بتحط الكيو هناك في الطرف الثاني وتحسب، والدلتا S of the system you can find it from what? Usually from
Tables.
Exactly, tables or other. Okay, that's why actually this is important for the calculation of how much entropy you produce within your system. حتى لو ما تعرف وش السورسز اللي قاعد تعطيك entropy, you can still calculate it from this equation. Okay, just to clarify, this delta S اللي هي ايش؟ اللي هي S2 minus S1. Okay. طبعا if I want to write it in a differential form, just this is just a tip يعني ds equals dq over t plus theta sigma. Okay, this is just the integral form of the entropy balance. Okay. طيب لو تلاحظون يا شباب، إذا ما عندي entropy generated within the system، شوف الحين برجع لكم سبحان الله كيف الانتروبي بالانس ترجعك للبيسك understanding, basic concept. If I have no irreversibilities within the system, الدي كيو هذه الدي سيجما الدلتا سيجما هذه كم بتساوي؟
صفر.
زيرو.
So I have no internal irreversibility, صح؟ It will give us what? It will give us ds equal dq over t for internally reversible. سبحان الله، رجعنا. فهمتم الحين ليش احنا هناك we defined ال ds as over t? Because I don't have any internal irreversibilities. My term here is 0 for internal irreversibility. That's why يا شباب when we introduced the area under the TS diagram and we said this is the heat transfer, this is only applied for internally reversible. For irreversible processes or internally irreversible process, you cannot apply the area curve because you have a generation term here you should take into account. So you cannot take just the TS diagram. وضحت الحين? Is this clear?
Yes.
Okay.
Yes.
طبعا if I have this term, if this term is greater than 0, معناته الentropy transfer into the system or out of the system, very similar to the heat transfer. If this is greater than
system.
exactly, so you have entropy transfer into the system. If I have this as is negative, this is what? Entropy transfer out of the system. Okay. طيب يا شباب الترم هذا وش ال possible signs for it؟ يلا your understanding now.
should be negative or zero.
شلون negative؟
Positive or zero.
It's a production term. It's entropy production term. Think about it.
not the strength.
Positive or zero.
If you don't produce anything, this is zero. If you produce something, it will be positive. So the only options for this term, ya shabab, and this is very important concept now. If this term is either positive or zero, okay? If it is positive, it means I have what? I have irreversibilities in the system. Irreversibilities present.
دكتور
This is no irreversibility. Yes.
دكتور السيجما ذا هو نفسه اللي قلنا سترينث شيء كذا كان اسمه سترينث.
لا تخربط، ما له علاقة.
اوكي.
لا هذاك حق هذاك في الكلاسيس inequality. لا ما له علاقة.
ايوه صح.
Irreversibilities, no irreversibilities in the system. Okay. خلاص, that's it. يعني that's what I wanted to discuss with you. I will review it inshallah next class, and then we can continue with examples. And we'll take inshallah examples. Any questions? Any questions? Any questions?
يعطيك العافية دكتور.
لا واضح. يعطيك العافية دكتور.
الله يعافيك. بالتوفيق ان شاء الله. شباب المفروض كلكم تاخذون A+, يعني ما لكم داعي والله. يعني تشوفون المواضيع سهلة، يعني ما في حاجة.
سويها والله يا دكتور.
You can. يلا موفقين.